Ever wondered why tree pruning is considered a crucial step in data mining? Well, let's dive into this fascinating topic. Tree pruning, in the context of data mining, is much more than just a random procedure. It's an essential practice that significantly contributes to the accuracy and efficiency of decision tree models. See, decision trees have a tendency to overfit data. This means they can become so complex, so detailed, that they lose their ability to generalize from the data. That's where tree pruning comes in. By cutting back the branches of the decision tree, we can reduce overfitting, making the model more accurate and easier to interpret. Moreover, tree pruning simplifies the decision-making process. It helps to eliminate unnecessary or redundant nodes, leaving us with a streamlined, more manageable decision tree. This makes it easier to extract valuable insights and make more informed predictions. So, tree pruning is not just a random step, but a necessary one in the realm of data mining. Now that we've established the significance of tree pruning, it's time to delve into its process. Let's walk through it one step at a time. First off, we start with the creation of a large decision tree. Imagine this as a massive tree with numerous branches, each representing a possible outcome or decision. This tree is created using a set of training data, and it's designed to be as accurate as possible, capturing every minute detail of the data. However, this is where the problem lies. The tree may be so comprehensive that it starts to fit not just the underlying patterns, but also the noise in the data. This is called overfitting, and it's something we want to avoid. This brings us to the next step, pruning or trimming the tree. Here's where we start removing the branches that are of least importance. But how do we determine which branches are less important? Well, we use a validation set of data to evaluate the impact of each branch on the overall accuracy of the tree. If removing a branch doesn't significantly reduce the accuracy, then it's deemed unnecessary and pruned away. This step is repeated until we're left with a tree that's simpler, yet still accurate. The final step is evaluating the pruned tree's performance. We do this by using another set of data called the test set. This set is different from the training and validation sets and allows us to assess how well the pruned tree generalizes to unseen data. If the pruned tree performs well on the test set, it's a good indication that we've successfully reduced overfitting and optimized our decision tree. As you can see, tree pruning is a systematic process that aims to optimize the decision tree. It's a delicate balance between keeping relevant branches and removing unnecessary ones to ensure the tree is not overly complex, yet remains effective in making accurate decisions. This is the crux of pruning in data mining, a critical step in creating efficient and reliable decision-making models. Let's take a moment to summarize what we've learned about tree pruning in data mining. This essential technique plays a critical role in refining our decision trees, making them more efficient and accurate. Firstly, tree pruning is indispensable in combating overfitting. Overfitting is a common issue in data mining, where our model becomes too complex, fitting almost perfectly to our training data. While this may sound like a good thing, it's not. An overfitted model tends to perform poorly on unseen data, as it has learned the noise or random fluctuations in the training data as concepts. This is where tree pruning comes in. By trimming down the decision tree, we eliminate branches that add little value, effectively reducing overfitting and improving the model's generalization capability. Secondly, tree pruning enhances the accuracy of our decision trees. By removing the less important branches, we streamline the decision-making process, leading to more accurate predictions. It's like clearing a path through a dense forest, making the journey from input to decision much smoother and more direct. Next, tree pruning simplifies the decision-making process. A pruned tree is easier to interpret and understand. It's less complex, less convoluted. This simplicity is vital in data mining, where understanding the rationale behind predictions can be as important as the predictions themselves. Finally, let's not forget the step-by-step process of tree pruning. It starts with the complete decision tree, often grown with the ID3 algorithm. Then, using measures like error rate or complexity, we identify the least important branches. These branches are then removed, and the process is repeated, leading to a pruned tree that's both simpler and more accurate. Remember, tree pruning is an essential part of data mining, and understanding it can significantly improve your data mining skills.